So today is day 2 of complex number operations. We are going to skip the simplifying and go straight to some examples. So today we are dividing, okay? And the rules for your I, your imaginary number I, are the same as for square roots, okay? So when you're dividing, you cannot have an I in the denominator, which means we have to rationalize. Okay, and we're going to do that using conjugates. So let me start with some fairly simple examples first. So if we have something like 2 over 9i, okay, we cannot have an I in the denominator because I represents the square root of -1, and so it would be like having a square root in the bottom. So the way that we move that away from the denominator is we multiply by the exact thing in the denominator. So we're going to multiply the top and the bottom because you can't do one or the other, right? So you multiply the top and the bottom by 9i. So when you do that, on top you're going to get 18i, and on the bottom you're going to get 81i squared. So we talked about yesterday, I squared is actually what? -1, right? So we're actually multiplying by -1 here. So on top we still have 18i. On bottom we now have 81 times -1, which is -81. Because these will reduce, 9 will go into both of them. We end up with a negative out in front, right? And we divide both by 9, and so we end up with -2i over 9. And we no longer have the I in the denominator, and so this is considered rationalized. Oops, I'm sorry. So, for our second equation, our second example, excuse me, we're going to do one similar. This time it's going to be 2 over -8i. So can we have a negative in the denominator? Sure we can. So for this one, we don't have to multiply by a -8i. We can just multiply by 8i because that's the only thing that cannot be there. So we multiply across the top and we get 16i. Multiply across the bottom and we get -64i squared. So we do the same thing as we did in the first one. I squared is actually -1, so we're multiplying by -1. So on top we have 16i. On the bottom we have -64 times -1, which is +64. 16 will go into both of these, so we end up with I over 4. Okay? So moving on to some that are a little more challenging. If we had in the numerator -8 plus 7i divided by 2i. Okay? So now in the numerator we don't have just one term, we have a binomial, and it's a complex number with an I in it, right? So we're going to have a little bit of extra work. So we're still going to rationalize by multiplying by the denominator. So I multiply by the denominator on top and on bottom. When you multiply by the 2i to the complex number here, it has to be distributed, right? So we distribute it to the -8 first. 2i times -8, -16i, and then 2i times 7i is +14i squared, all over 4i squared. So we have to simplify a few things. So we're going to have I squared here, which is times a -1, I squared here, which is times a -1. So I end up on the top with -16i. 14 times -1 is -14, so we're subtracting that, and 4 times -1 is -4. Now this is not in order. Remember we talked about yesterday the proper order is A plus or minus BI. So we need our I to be in the back. So I'm going to move that first. So I'm going to have -14 minus 16I all over negative 4. And all three of our numbers, only when all three of your numbers are divisible by something can you reduce those. So we're going to divide all of those by negative 2, and so I will end up with 7 plus 8i over 2, and this will be our answer.